Right. Okay. And you're live, so you muted. I just hit. Was it orange? Get your presentation up here. Coordinate. That's the clicker. Oh, right there. Okay. Laser doesn't work, right?
The laser doesn't work. No, you just hit the forward arrow.
And this one's live?
Yep. All right, here we go for day 2. Hope everybody enjoyed that tour. This facility is amazing, and we're thankful that they let us use it for the conference. And the product demos were pretty cool too. Hopefully you'll be at FabTech. You'll see all that again at their booth. So it's time to begin our next round of presentations this morning, and we've got some really great case studies. Again, we're always appreciative when companies are willing to share what they're doing. In this case, with some Industry 4.0 and IoT activities. So our case study this morning is with Flexco, which is a manufacturer of conveyor belt accessories and maintenance products, which are used in a variety of industries. So here today from Flexco is their manufacturing manager, Dan Tuttle, who's worked for Flexco in Downers Grove since 2004, started as a press operator and CNC machinist, and Dan now leads its stamping department, and he's helped recently take Flexco's highest volume product family using IoT and machine monitoring technology to increase overall productivity by 25%. Joining Dan to help tell the Flexco Industry 4.0 story is John Daly, Senior Account Executive with Machine Metrics. John's career started in the automotive supply chain, developing plant floor applications and supporting operations teams. Later, he worked at Plex for 12 years, leading ERP implementations in the automotive, aerospace, and other vertical markets. So please welcome John and Dan.
Morning, everybody. How's everybody doing? Thanks for coming out. You know, a few years ago, I was in your same position, right? I was sitting out there getting ready to listen to a speaker talk about a topic I knew very little about, and it was Industry 4.0. And I bet right now, some of you are thinking the same exact thing now than I was back then. It's like, man, this presentation might stink, but at least it got me out of the office for the morning. But I'm here to assure you that this presentation is not going to stink today. I want to share some of the examples, both big and small, that Flexco was able to implement with the help of Industry 4.0. And just even some of those small implementations that we did to help improve our overall utilization, we may not have even realized if it was not for Industry 4.0. And we'll get into more detail about that in a little bit. So my name is Dan Tuttle. I'm a manufacturing manager for a company called Flexco, about 20 minutes south of here, located in Downers Grove, Illinois. Flexco was founded in 1907. We provide products and services for conveying systems. So anything related to a conveyor belt, we probably have outside of the belt itself. Installation tools, the fasteners, the cleaners. We're in a lot of facilities such as parcel. So Amazon, FedEx, UPS. During COVID, we kept everybody moving. And then we do coal mines, potash mines on our heavy duty line, salt mines, for example. Hay balers. About this time of season, you drive by a farm, you'll see the hay bale, whether it's square or round, which is actually regional based, and that's a whole nother story. But that's all of our fasteners making the world turn. We have 860 employees globally, 12 subsidiary locations, subsidiary and manufacturing locations across the world, and we support over 1,800 distributors worldwide. Me personally, I started with Flexco. I'm going to take you down a little journey here, so bear with me. So I actually started going to Flexco when I was about 6 years old. My uncle worked there. I went for Take Your Kid to Work Day. I didn't know what I was getting involved in. And during high school, I worked there all 4 years. I'd go to high school during the day. I did a machine shop class in the afternoon, and then I go work at night, just doing light assembly, inspection, stuff like that. I wasn't 18 yet, so I couldn't run a machine. After high school, graduated in '02. They didn't have a full-time position for me, so I left. Did a couple different things, gained some experience, and actually got a call back in 2004 is which one I started with Flexco full-time. Started at our stamping operation, which we're going to be talking a lot about today. And I ran a punch press for about 7 years. Really loved it. Still, to this day, one of my favorite jobs in the building. And after that, got promoted to CNC department where I learned setup, operation, programming, stuff like that. While I was working in CNC, I went back to school, got my business degree our bachelor's degree in business, and graduated from Benedictine University right here outside of Chicago in 2017. And that's when I became a manufacturing manager. So full circle, I now manage both departments I've worked in at Flexco. So just kind of a fun little story I just wanted to share with you guys so you know my background and that. So with that, I think I'm going to turn it over to John.
Yeah, I just have a couple slides, really. Brad already gave a nice introduction on both me and Dan, so we don't need to get into that. But just to give you a little background and context for what Dan is going to share with you today, a little bit about machine metrics. And so obviously, you see our customer and some of the statistics here. What we do is we're a industry-leading platform that is really focused on connecting to machines. And so that's really our focal point, is being able to easily connect into that equipment and those machines. In companies, multinational organizations, such as Regal or Fastenal, but also small mom and pop shops run machine metrics and everything in between. And so I got another slide that comes up here, so I'll go ahead and advance that. So, as I mentioned before, this kind of gives you a little bit of a scope of some of the types of equipment we connect to. You're going to see in CNC lathes, mills, and grinders, but also, we've developed, connections into modern automation equipment like cobots and robots, as you see, but also stamping equipment. And that's actually the use case that we're going to cover today here with Dan is a stamping press, although they also have CNC equipment such as Mazaks and DMG Moris, et cetera. So the last little piece on machine metrics to give you that additional context here of how we gather those insights and that data from the machine is first we connect to the equipment. We do that through a lot of our intellectual property is inside this green box here, this virtual edge device, where we've developed the connectors and adapters to speak directly to that Amada equipment that we just saw this morning. But not only Amada, but for Mazaks, for DMGs, Kitagawa down the road, et cetera, about 300 different adapters. And so our philosophy is a little bit different, is we want to make that connectivity into your equipment really easy, into those PLCs, and make it a plug-and-play experience. And be agnostic across manufacturers, instead of just having a specific point solution that is relative to that manufacturer. That's kind of a big difference, what you'll see. And we'll talk a little bit more at the end of the presentation. And what we'll do is take those data points and those diagnostics from that equipment, and we centralize that into our cloud platform. And that's a secure, reliable, a platform where we perform analytics on the data. And then lastly, we deliver applications right down to, what you'll see today is with Dan in this use case is we deliver applications right to the floor that, out of the box, apps that you can take advantage of the moment you connect. Or if you're so inclined, you can, of course, develop your own apps through a very modern connectivity protocol. So let's go ahead and let's get to the use case. All right, go ahead, Dan. Oh, yep, sorry.
Thanks. All right, so can you guys hear me okay with this? Okay, so where did we start at Flexco? Our current state, pre-2020, before we even get into Industry 4.0, utilization, OEE, that was a big thing for us to track. About 5 years or so before 2020. It was something I personally did through spreadsheets, and we didn't have all this fun technology, and it was very cumbersome, up to 8 to 10 hours a week just to figure out what we were doing. So pre-2020, we hooked up we went to Industry 4.0, hooked up machine metrics. We saw that we were getting as low as 20% utilization off of my stamping presses, 2 100-ton Minster presses. So that was a problem for us. Production match sales. So we produced about 2 million strokes per month, and that's exactly about what we sold every month. So we had no room for error. If a die went down, if a press went down, we were falling behind. We had downtime that we could not articulate, and I'll talk about some of that in a little bit in an example. And we were facing 5 to 7% growth over the next 3 years. One of my first tasks coming on as a new manager, my boss asked me to present to the executive team to go to a third press operation because we saw this growth coming. We saw no end in sight and how to keep up with it. So put together a presentation, and they didn't approve it, but they said, it's your data's good. We see why you want to do it. What we want you to do is squeeze every last ounce of utilization out of your current process. So they challenged me with that, and I took that personally. So that's what I did. So let's fast forward to July of 21. Part of COVID, stress levels were super high, as I'm sure most of you felt as well. Uncertainty was at an all-time high. We didn't know what was going to happen. So on top of all that, we were hit with a 5-week back order on stainless steel raw material, which I'm sure you guys felt as well. That threw our shipping metrics into a tailspin. We normally ship 95% of our orders within 1 day of that order date, and that metric was down about 40%. So we weren't sure what to do. Before we knew it, we were in a 4.3 million stroke backlog. It equated to about 3,500 back-ordered lines and over $1 million in delayed revenue. So to put that into perspective, we talked about production matching sales. So if we're producing 2 million strokes a month, we're selling 2 million strokes a month, how the heck do we come up and make up this backlog? We tossed around the idea of doing a 7-day operation. Obviously, that raises overtime costs. The work-life balance for our employees wasn't going to be there. And even then, even doing that, we were still looking at well over a year to recover from this. So here's a sneak peek of our operation right now. This is one of our presses on our shop floor. We have 2 of these, and they stamp out those fasteners you see at the top of the slide. So we had a lot of questions. We had this big backlog. How are we going to do it? Production match sales, yada, yada, yada. We focused on what we knew. We knew that we had a 2-press operation. We knew that production matched sales, and we knew that we had no room for error. Then we started looking at what we don't know. Was our issue an efficiency thing with the machine? Was it a capacity issue? Was it a personnel issue? It's just things we did not know. So what we were going to do about it, that's when we started actually utilizing Industry 4.0 and machine metrics. So we've had this hooked up for about 1.5 years. We got some good data from it. That's when we drove into action with it. So we decided to hold these weekly meetings, look at the data from the last week. So during these meetings, our goal was to drive down downtime as quick as possible. Fail fast, move on, because again, we were still in the heart of this big back order. The problem with that is we face some adversity. So from an operator standpoint, I'm sure a lot of you guys have felt that as well. You get the big brother, right? this machine's on my machine now, and it's looking at everything I do. Every second I'm down. And we took that personally, and we wanted to make sure we implemented 4.0 the right way. We never whipped anybody for underperforming metrics, even though maybe we should have. We knew that it was more important to get the buy-in from the operators in the shop floor on something like this before we even took it to there. And it worked. So our plan was just to be consistent with it. We held weekly meetings. We did it on Wednesdays. We would come up with a task list based off our top downtime codes. So this is actually a Pareto chart I pulled right out of Machine Metrics, a real life example, and we would look at this. This is one of the things we would look at in a meeting. We would focus on our top 3 downtime codes. If they weren't off shifts, breaks, lunches, because that's the stuff you do every day no matter what, then we dug into it a little bit more. You can click down and click down and click down. It's a really nice software. It's user-friendly. And so, for example, die changeover was way up this past week. So what caused that? We talk amongst the team. Was it extra die changeovers? Was it you had problems with one die changeover? Then we would dig into those issues and try to solve them. So we met on Wednesdays. We set a task list out of the meeting, and with a due date of that Friday. So the next week we start fresh, and we failed fast, we improved fast, and we moved on from there. So here's an example of one of the downtimes. We call it a bowl jam. So on our presses, we feed staples in the back of the press that get inserted into the press. When a bowl jam happens, it shuts the press off. Operators got to walk around, clear it, walk back, start the press. Is it a big deal? Probably not. Is it annoying? Yes. So these are quick 30 to 60 second stops that we were seeing. We knew it was a thing that was going on, but we didn't realize how much it was happening. So we pulled this out of Machine Metrics, and we didn't actually start looking at this particular downtime code until about June of 21. That's when we saw this was trending in the wrong direction. Those 30-second stops were costing us almost 2 hours a month. Now, it's not a huge number, but that's just something really small, right? Something that's you could fix in a 10-minute meeting, and that's exactly what we did. We identified this in our meeting. We walked right down to the press. We got automation involved. We made some adjustments to the controls for the bowls that cause these bowl jams, and now we're less than a half an hour a month. So again, a small win, but it was a big win. It's something annoying. It messes with your momentum as an operator. You know, you just want to come in, do your job, get good strokes, and go home. And this was a big win for us. And it only took 10 minutes, you know, but this is something that we would not have recognized if it was not for our implementation of Industry 4.0. So then I'm a very competitive person, right? I don't want to stop there. That's a small win. What else could we do? So we looked at our department. So 2 presses, and we pulled some data out of Machine Metrics, and we found that we had a 60-40 split on production. So 60% of what we were producing every month was coming out of one press and only 40 out of the other. Couldn't explain it. It's been set up like that for years, and nobody's ever challenged it, right? So we looked at that, and we moved some things around, rerouted some orders to the other press, and we were able to do a 51-49 split. What this does for us is it allows us to have less changeovers, have less downtime, have less troubleshooting from those changeovers. If we can have longer runs, we could be more productive, and the win in the end is increasing that utilization, you know? That was within our department. So again, the competitive edge in me, what else could we do? We're still in this back order. We're gaining some ground now, but it's not as quick as we want. We want to be able to fulfill our customer orders as fast as possible. So then we looked within our facility. So we have 2 presses. I tried getting a 3rd press a few years back. And we have 4 dies that run through those 2 presses. So we looked at another 100-ton punch press that we had in our facility, completely different department. It's never ran, our dies have never ran over there, but it was the same exact press. So we did a little Gemba, figured out what we needed to do to modify the bolster and what have you, make sure everything was safe, and we put our dies in that press. Before we did, that press was only being utilized 5% of the time. It was eye-opening when you look at the numbers. You walk by, you hear it running, you just assume everything's good, but it was only being used 5% of the time. So we put our die in there, and that instantly, the very next month, bumped up that utilization for that press up to 23%. I mean, 5 times over. It was a great win, and it was able to help us cut into our backlog that much quicker. Any questions so far? I feel like I'm babbling. Get a drink of water here. So, goal setting. Oh, yeah, go ahead. It was eye-opening. It really was. No, they actually welcomed it. They saw, so Flexco's culture, it's really great. It's, one of the key points is called Better Together, and that's it. We live it every day. Everybody wants to help each other out. And when we presented that to that department, you know, we worked together with them. We just didn't say, here, run our die and let us know when you're done. Our operators went over, trained that operator on how to run our dies. They trained us on how to run their press because the controls were a little bit different. It was a really great collaborative piece, you know, and it helped them with their numbers too. So thanks. So goal setting. We've implemented all these improvements. We're starting to see utilization creep up a little bit, but again, I know I keep going back to what we're still in that back order. So what we had to do is, so 43,000 strokes per shift is our current goal. Just normal operating outcome, or any operation, I should say. But we had to bump that up to clear back orders quicker. So what we did is we bumped our goal up to 55,000 strokes per shift. So to an operator, that's like, oh my, you want 12,000 extra strokes? That's an extra hour and a half of running. How are we going to do that, right? So again, we got together as a team, collaborative meeting. How do we get 12,000 strokes out of each of these presses? So we came up with, it was just me and my team. It was not senior management. It was not anybody else. It was just me and my team. And we came up with running through breaks and lunches, you know, or alternating breaks and lunches, I should say. So you go to lunch early, I'll keep the machine running. Shift change, we kept the machine running. Rather than the 15-minute flash meeting we normally would have, we would keep the press running and they would just talk over the press, you know, and hey, this is what happened today. This is what's going on. This is where you're at. And it was fun to watch because they were hitting this, right? And I'm really big on culture and motivation and all that. And so they were hitting this. We were talking production numbers every single day. I was keeping them up to date where we were with back orders, how we were the day before with production. Did we hit our goal or not? And that drove on its own internal competition, right? So next thing I know, they're hitting 70,000 strokes a shift. It was unbelievable to watch. Almost doubling their original goal, and they were doing it on their own. You know, they would come to meetings, the update meetings, and yeah, I beat you, no, I beat you, and it was fun. Quality was never sacrificed along the way for it, and it was just another feather in our cap and another big win throughout this entire journey. So we had this large back order. We've improved some of our processes, and we implemented 4.0, and that equated to progress. This is when we started seeing things fall off, stress levels go down, everyone was a little bit happier. Like I said earlier, 3,500 back order lines was our peak in September, once we finally got that stainless material in, and we just saw progress from there. Utilization numbers went up, back orders went down, and by June of this year, we cleared our last back order. It was a 10-month recovery from something we were expecting, and we were telling our customers that it was going to be well over a year. So all of these efforts, utilizing machine metrics and Industry 4.0 is what led us to this and being able to give our customers their product about 5 months early. So this is where we're at now. Everything's normal operation. When we first turned on machine metrics, we were about 28% utilization. Over the past 2.5 years, we're up 32% to 37% utilization. It's a big win for us, and it's just something that we're really proud of. Just putting the work into implementing it all. I mean, once all the software was in, it was easy from there. It really was. So I told you guys this is one of my favorite parts of the job is motivating folks and keeping them engaged in the culture within a department. We celebrated those some milestones along the way. You know, our back orders, say we got down to 700,000 in back orders. We had a team lunch, right? I wanted to make sure the guys on the floor were still motivated. They were doing okay. They were spending a lot of time away from their families, and I wanted to make sure they were good. So we celebrated those wins. We never went crazy because we still had a job to do. We still had a back order out there. So quick 30-minute lunches, whatever they wanted, brought it in, ate, and went back to work. During this whole time, so when I first started, I told you guys the third press story, right? Very competitive person. The goal for the production record, I should say, for that department was about 1.5 million units a month. It's something that, as a manager, new manager of the place, I wanted to beat. I hung it up on my door, and I looked at it every single day, and that's what drove me to do my job, right? During this recovery, we broke that record 3 times. Not even trying. We were just trying to cover back orders. We broke it 3 times, and we were damn proud of it. So we had a huge celebration at the end. Back orders were gone. We had 3 production records. As you can see, we produced 2 million units in a single month, which is 4 million strokes. Our average before was about 2 million strokes. So we doubled our production that month. It was just a really fun time. The guys got whatever they wanted for lunch. Cost was not an option. We just celebrated it. And, you know, part of that celebration, everybody came down. It was the president of the company stopped by. My boss was there. Marketing was there. Planning was there. We included everybody because it was a true team effort through this whole thing, right? So we surprised them with a gift bag. They got, you know, mugs with motivational quotes on there. But then, you know, we gave them gift cards to, and it wasn't a $5 Subway card. It was a, hey, go out, take your family out to eat. You spent a ton of time here the last 10 months. You deserve it. So take your time, you know, take your family out to eat. And then kind of wasn't a gag gift, but this is something I did personally out of my pocket. I made these shirts for these guys because it was, like I said, it was a goal of mine. They knew it. We worked towards it and we hit it. And I'm happy to say that these guys wear these shirts every single week, just as a sense of pride and accomplishment. And they've really brought the culture in the department up to a whole new level. You know, when we have an opening, we have 40 internal candidates that apply for this job. And it's just a place that people want to be. And it's kind of cliche, but it kind of all started with all these improvements when we introduced Industry 4.0 and machine metrics 2.5 years ago. You know, because we made the job easier. We made it better. We made it fun. And it just told a story along the way, you know? So that's what I have. Is there
All
any
right.
questions?
We have a couple more slides, and then we'll have a little bit of time at the end
Yep.
to have some questions as well. So to kind of give a little more background, now tying in the kind of the use case that Dan described, a little bit about Machine Metrics platform, and kind of tie that back into what Dan described today. So really, Machine Metrics, our philosophy is a little bit different than maybe a traditional MES or ERP system, in that what we're focused on is one, connecting to that equipment and that machine, and have that machine data drive people and systems, versus, you know, having a manual input, let's say on a screen, and laboring, or let's say burdening that operator to have that input. You know, what we want to do is take away that and make the operator focus on what they're good at, and being a machinist or being a stamping operator, et cetera. And so Machine Metrics is, you know, kind of 3 core pillars of that data feed, really comes into that connectivity layer down below here. And then what we're doing is we're connecting into the machine controls as described. We're connecting directly into sensors and relays right on that equipment to sense things like machine utilization and strokes, like Dan was doing, part counts, right, on a very simplistic level. But also on a sensor standpoint, in a CNC or a stamping press, you know, be able to install tonnage sensors, right, to be able to understand of when maybe that particular that die is experiencing wear, and perhaps experiencing let's say quality issues. And then in addition to that, ancillary equipment, like in a CNC, obviously there's a lot of internal sensors we can connect into, but external sensors as well. So, you know, on a CNC, you're gonna have a coolant tanks and levels and the quality of that coolant. There's thousands and thousands of different sensors that we can tap into. And there's also a very exciting technology out there called IO-Link that basically auto-calibrates that sensor, and it allows us to be able to auto-map that data point in Machine Metrics, and then hence set thresholds and conditions through condition monitoring, which is one of these, our solutions here, to then build out notifications and workflows that would then transfer into either other business systems or simply the maintenance team or the operations team. So that's a little bit on that connectivity piece. That's really fundamental to machine metrics is getting that nut cracked of connecting to that equipment and identifying the key data points to make you successful. And then over here is I'll talk a little bit more about this, is four main value pillars, I would call them, is utilization monitoring, production monitoring, condition monitoring, and tool monitoring. Over here on the right is we consider, as I mentioned, is a best of breed software, IIoT platform for machines. We have customers integrating into their MES systems, integrating into their ERP systems, providing that data back, real live cycles, actual cycle times like Flexco does, to utilize that data to represent what's really my standards, what's really my setup times, as an example, and have that closed loop process back into those business systems to then obviously realize what's actually happening and self-correct itself over time. And then business systems are analytic systems like Power BI and Tableau, maintenance systems. We can meter the machine in terms of hours and cycles and pass that right into a maintenance CMMS system. Obviously using that for more, a proactive maintenance versus a calendar PM focus. And then lastly, incorporating quality data and work instructions. So I'll just quickly hit on these four pillars and kind of give you a little description, and then we'll open it up for questions. So as mentioned, utilization, what it comes down to is my machine running or not. That's increasing that shop floor visibility like Dan just described today. That simple visibility of getting that connected and seeing what my machine utilization is, within days or weeks is extremely impactful and allowed them to come out of that COVID hole, basically of that extreme backlog of $1 million. And then it's also very beneficial in the use case that Dan provided in terms of looking at deferring capital expense or CapEx. He was considering another press. Well, they were able to quickly and were challenged by their leadership to say, let's do with what we have in-house. And you prove it to me, Dan, that we are capacity constrained. Well, using that data that was actual real life utilization data, that 5% showed an opportunity, obviously, to be able to squeeze in more capacity on that equipment and repurpose that press for something that was not being utilized. So that's what utilization is really strong at doing is understanding, making that CapEx decisions, and then also labor decisions. The next one, I mentioned a little bit about the condition monitoring. This is a huge value pillar, as mentioned, is be able to basically, contribute to that reduced downtime and optimize those maintenance programs. Every little piece, Dan shared some small wins, but there's a lot of little small wins behind that bowl jam issue he described. That all contributed to that improvement and improve utilization, and condition monitoring is one of those areas where you can leverage and continue to get insights and act upon issues at the moment it's happening to avoid the quality problems and avoid the machine down problems. So condition monitoring is again, a very important piece of realizing that value. And then production monitoring, simply part counting, right? And understanding, on the, oops, let me go back. Understanding, how many parts we're producing against, our standards. You saw it come full circle. Dan and team basically, I'll just jump to the next, slide. When they deployed machine metrics on the floor, either at the operator level or in the dashboard level, basically that production monitoring held their team accountable. They didn't force feed that onto their team members. They worked with them. But basically what it comes down to is when the machine's in green and I'm hitting my targets, I'm feeling pretty good. If it's orange or red, you know what? It encourages accountability, but also offers the opportunity for other folks to come in. Maybe it's a training issue. Obviously, we're in a high turnover environment, and we can work with those particular operators and up their game. So this is just to cap it off. Machine Metrics is, as mentioned, is very much focused on connecting to that equipment as soon as possible. We make that process very easy in our platform. And this is an example of companies that are connecting to their equipment and being live with Machine Metrics in days to weeks, not months to years, and deploying a solution like ours. And that's obviously a really important piece is that we have a different philosophy. Is we let's say, well, 80% of our customers today do their own self-installations. And so that's a testament to why our platform is making that easy. Of course, if you have controls engineers and maintenance teams that are perhaps not labor constrained enough to work on the installation of Machine Metrics, then that's possible. But we also have the staff and team and connectivity engineers to help facilitate that. So we're not a science project. You can get up and going really quick with Machine Metrics, and we can basically teach you the basic rudiments of how to get that connectivity and that data out of there and be live again. And it's a true statement. We just worked with a company recently. They had a bunch of CNC fan controlled machines. They plugged it in. It's more of a networking exercise, and they had 40 machines reporting dashboards like this within the same day. So that's kind of the difference here is the return on value is quick with Machine Metrics for those reasons. So we probably only have a couple minutes. Let's see. We have 6 minutes, I believe. Any questions for me or Dan?
Questions for these guys?
How do you guys plan to scale up? So the Machine Metrics element is great, and you see all the utilization and stuff like that, but how do you plan, I guess, for FlexPro, how do you plan to go and take the data deeper into your enterprise as far as, bringing that information, calling on the ERP systems for ordering or parts and trying to actually get
Sure. I think our first step,
back in?
yeah, our first step is going to be just implementing it across the facility. We've had some great wins on some high volume product, and it's gaining that buy-in from everybody else and seeing what's actually out there. John mentioned Tableau reports and stuff like that. We've just implemented Tableau. Actually, we went live this week. So it's going to be great to combine these two and see what we can get out of it. I mean, just to be a little bit more proactive and even more reactive. Before when I had to do all this stuff by hand, I mean, you calculate everything for a month, takes 8 to 10 hours, blah blah blah, and you're always a month behind. Now it's a couple clicks. You get the same data I did before, and then you can go have a Gemba walk with your team. And hey, this is what I'm seeing. Day by the hour is really big right now. We're going towards that method as we speak. We're starting to implement it, and this is going to be a great tool for us. I mean, it's live, it's there, and it just prompts conversation and improvements. Hope that answered your question.
Hi, Dan. Thanks. You had a slide where you were talking about weekly department meetings where you kind of went over downtime, reasons for downtime. So we're kind of, our facility, we're venturing into Industry 4.0 and probably into some things like cycle tracking, cycle rate tracking. So I'm just kind of thinking through how we'd approach that. If, when you guys had those department meetings, was that with operators saying, hey guys, why, we had this issue with a lot of downtime for a tool issue? Was that did you guys just do that kind of at a supervisor level, or did you include operators in that as well?
Sure. So the best part of that is it was just me and my team. My boss wasn't there. His boss wasn't there. It wasn't a big thing, right? We wanted to do it on our own and just show the improvement, right? obviously in case settings like this and at work. But yeah, we got together, we talked to those 3 downtime codes. And again, that was just one portion of that meeting. We celebrated wins. Hey, we did this week. We did this week. And I started the meeting off with the wins, almost like the compliment sandwich thing, right? You start with the win, then go to what we need to improve on, and then go from there. But yeah, it was all with the team. Sometimes we resolved some things in the meetings. Sometimes they led to the Gemba walks like we talked about and doing the bowl jam thing. And some were a week or 2 long tests that we had to get done where we needed a couple more resources. A lot of the buy-in that we saw came out of those meetings with, yeah, the tablet's not working. It's not doing this. It's not doing this. Half the time it was training, and they didn't understand how to use the tablet and use the software. When it was a machine metrics thing, these guys were on the phone, literally, I'm not even joking, the same day, and they had it up and running. And when the operators saw that response time from management and machine metrics, they had instant buy-in. So, thanks.
Dan, I assume you get all this data available to you on your phone?
Yep, I have the shortcut anytime I want. Yeah,
Are you addicted to the data? Are you following it like?
a little bit. I can pull it up right now and show you what those guys are doing when I'm not there. So, but yeah, it is a nice tool to have. I don't use it too often at night because I don't want to be the spy. But just last week we were struggling with one of the dies, couldn't get it going. It was down for about a day. Just troubleshooting. Everyone's involved. And so I jumped on there, saw they were still having some issues. So I actually called one of the operators. And the nice thing about my role is I did the job for so many years. I can provide that support for them too. It's like, hey, did you try this? Did you try this? So there's so many different wins and advantages to it,
Do your supervisors have access to this data too?
Yep.
Or do they do?
Yeah, so like John showed, I mean, we have the dashboard of every machine we have hooked up in the facility on there. And I'll tell you what, I hate walking by and seeing my stuff red. So that's an internal competition thing for me as well. So, but yeah, everybody has access to it.
Interesting. Any other questions? Terrific. Dan, you guys should be really proud of what you accomplished. I know you are, but
Thank you.
it's amazing. I think everybody here is pretty impressed. So nicely done. Thank you for the presentation.
Thanks, everyone. This looks like my kid's room with all the water bottles. Is that you or is that me? I don't know.
Presentation up here. Thank you. So you just advance, unfortunately. That's right. All right, excellent. So we're going to keep our case study presentations going with Aaron Weigel from Weigel, used to be Weigel Toolworks, now you're branded as Weigel, right? So Aaron is the president of Weigel, and he's going to present his company's long-standing success with IoT technology. Weigel is a precision stamper specializing in electrical, automotive, tight tolerance terminals, complex lead frames, bus bars, and similar products. And the company was an early adopter in IoT. I think he's got a good story to tell about how he's using that technology. So please welcome Aaron.
Thank you. Okay. Good morning, everyone. So I was watching your guys' presentation, and I have a very similar story, although I started this journey damn near 20 years ago. I started, just a little quick bio on me, and then my background here. There we go. Oops. So similar background, family-owned business, 3rd generation. We're celebrating we already celebrated our 80th year. So I've been coming to the plant as a little child. Started at the company in 8th grade and worked in every single department, ran every single machine, did all the classes, went to Northern Illinois, got my degree from Northern Illinois with my an emphasis in manufacturing engineering, and just did everything there that you possibly can before I became president in 2010. I mentioned that I was vice president of stamping division from 2001 to 2010 because that was the time that I started the implementation of the IoT journey. I mean, I go back a long time because one of the things I noticed when I got there was, boy, I mean, it's just tool and die work and stamping is just an old, archaic thing. And I walked into new equipment, older guys, nobody knew how to type, nobody knew how to do anything on the computer, and I walked in scratching my head like, guys, we need to get some of this data onto computer systems, and they were looking at me like I was, just some college punk that didn't know what the hell he was talking about. But I started this early because similar to what Flexco was talking about, getting this data and using this data was important for us to react to it and attack the right jobs at the right time instantly rather than compiling all the data. Just real quick about the company, again, 80 years, 4 facilities, all within the Chicagoland area. We now have 207,000 square feet, and we do stamping, we do welding, we do automation, we do assembly work, but primarily we do stamping. My grandfather started as a tool and die shop, and that's where we were building tools all throughout the 40s, 50s, 60s, and 70s, and then my dad got into stamping in the 70s, and then that's why we dropped the Toolworks acronym, because now we're into a whole bunch of different other operations outside of just stamping. So that's one of the reasons why we're branding in that direction. So quoting what my dad told me early on, and I take this to heart because this is how we run this company. Similar to the ITW philosophy. You cannot manage what you cannot measure, right? Just think about that. How can you go attack something if you don't know where you're at and how you start this whole thing? So I took that to heart. So how do you get to the point where you're measuring things? There's 3 questions you have to ask yourself. The challenge here: what metrics are you going to manage? You have to identify from a management team, what are you going to target? Number 2, now that you have identified it, how do you get that data? Number 3, once you get the data, what do you do with it? Do you spend a month trying to compile it? Which we did too. We did too. So this is what I walked into. Every single press we had a little workstation with a clipboard and a pencil. And they would log in every 15 minutes, a code. Each code was designated to be downtime for whatever reason. And they'd type in write down their scrap quantities, manufacturing, they'd specify tool maintenance, quality inspections, box challenges. But I'll tell you what, when I got there, I saw that data. And there were 50 pages on the clipboard, all crimpled and folded in, and you could flip through it all. And I'm thinking to myself, we're doing all this. Who's looking at it? What are we doing with it? Now, it's valuable information. Don't get me wrong. But who the hell is going to go through all those clipboards and compile it onto spreadsheets and figure all this data out? And by that time, similar to what Flexco was mentioning, you're a month behind. It's like getting your financial statements 2-3 months behind. How do you react and how do you run a business that way? So, again, the positive points of getting the data, yes, the data is available to analyze and troubleshoot, so we can go back in history. Timestamps are available with codes to determine whether issues arrived and who oversaw them. I mention that because I got a funny story about, I'll just call it data manipulation between first shift, second shift, certain operators. So the data that they were typing in or writing in, handwritten, sometimes wasn't truthful and hiding mistakes. Where when you get this data online, there's no lying, there's no hiding. Negative points, again, data collected but not automated and compiled. Although the data is available, data is not conveniently real time. We talked about that already. And then data could be inaccurate in some cases. And that's what I was mentioning earlier. Real quick story, we were doing really well on this one tool on our 100-ton Minster on the first shift. Second shift, we're producing half. Went on for months. Talked to the operator, yep, I'm doing the same thing. And come to find out, he was cranking down the speeds. Couldn't know that until I saw what was going on the event log. Then one day he had a crash. Screwed up the whole stripper, broke the die inserts. I asked what the hell happened. Don't know. Did you have your sensors on? Oh, of course, Mr. Weigel. Well, it happened again with my internet on. Sensors were turned off, and I knew exactly what was going on. He was fired on the spot because he was lying to me about the whole thing. But that set the culture and the journey right then and there when we did go live. So I did my research, and that's when I started early on with, if you're familiar, and I'm not a spokesman for Shop Floor Connect, but this is what we just did. But I started with PACnet, which is 2 iterations before Shop Floor Connect by Wintris. So early on, this was the box. I'm sure all the guys, snappers here, they're familiar with this box. I ran those RS-232 cables throughout the entire plant, all to one central database. Just, you know, hundreds of yards of cabling. And it was slow data getting to the computer base, but you know what? I just eliminated a month's worth of the data collection and moving that information from the clipboard to now electronically and getting it onto Excel sheets to do whatever I needed to do in Excel to figure out what was going on. So this was the beginning stages, and again, that was the other thing too. I had live data. Delayed, 20, 30 seconds. So what? Live data, it gave me a specific machine, what tool was in production, the quantity that was produced, run rates, event logs, tonnage and sensors, important information there with the tonnage and sensor monitoring. So it was all routed in my office. I was the only person that had this database. Anybody could go up there and see it, but that was what my tools were as vice president of stamping at that point in time, to know real time what was going on. Big investment, right? But the way I see it, you know, we're all in the same industry. Touch a press under $700,000, $800,000. For the big boys, $2.5, $3, $4 million. When you have 23% utilization, it's worth the investment. So yes, we did invest in all the smart packs from DiPro 1000, got them up, the cabling, did all that. Positives, moved from the manual clipboard to the electronic database. The electronic data was uploaded into Excel, so I had preloaded templates. The data just populated. I was way ahead of the curve coming in as a college graduate in engineering versus, and I think I was like one of 2 college graduates when I came in to my dad's company in 2000. It was my dad and I. Today, I think we have well over 15, 18 of them, and I'll get to that in a minute about why it's important to have engineers and what their roles are and what they do that help with this, with getting this data to steer them in the right direction of what they're going to do and target the right jobs to get your best bang for your buck. So live data was coming in, and then also it was nice too, backing up the workstation programs. I was able, any type of program that we uploaded into the Smart Pack, any type of sensors, because that was the other thing I noticed too, and I actually didn't put this on a slide, but just reminded me of it. Part of the downtime reasons I was having is, you know, we have similar family presses, 300, actually now 400 tons, 260 tons, so on and so forth. But the setup times between all those different dies, between each press, were staggeringly different. And I asked myself why. Was it the operators? Lack of tools at the press? Well, the biggest thing that was really easy to solve was when I was downloading all these programs, my material buckle sensor on press number 1 was sensor 1. And then it went to sensor 3 on the other press and sensor 5. And then when you jump from program to program within that same press, that same sensor that you have at that press kept on moving from slot to slot in each program. It wasn't standardized. And it was eye-opening to me to see all that, because it's hard to see that on the floor, but when you download it all and you see these programs, I immediately just standardized all of the sensors, where they belong to on the ports, programmed them all on the machines, backed them all up, and now I have backed up files in case the Smart Pack crashed out, or if we wanted to buy another machine, I could just, boom, upload all the programs right to the machine, and it was all uniform, cut our setup time immediately just from doing something that stupid where we're just different sensors and different plugs from job to job on the same press. Negative points. Delays. But again, 15, 30-second delay, I'm not going to cry about it with RS-232 cables. That was the best at the time offered at that point in time. Lack of automated reporting. We're going to get to that, but PACnet gave me the data. What I did with the data was a different story, but they didn't offer the reporting, but I at least got the data off the clipboards. Lack of visibility of additional users within the plant. So this particular software system went to one central computer, and I was able to see it from one machine at my desk. It wasn't plant-wide and even multi-facility wide. So lack of data via internet inside and or internet outside of the physical plants. That's what I was talking about. Like, we mentioned earlier about whether or not we can get the data on the phone. I got it on my phone. I see it constantly today, but that wasn't available back then. And also, it was only limited to mechanical presses at that time, which was our core business. But as we grew and as we got involved in other pieces of equipment, that was no longer acceptable. And Wintrust knew that. Then the next upgrade came. LETS, the line efficiency tracking system. I'd say I'd probably put this in 2008-ish, 2010-ish. Again, this was another hardware upgrade. I'm sure everybody's aware of the SmartPack 2. It's a common device that's on presses today. So it was a hardware upgrade, so we had to convert from SmartPack 1 to SmartPack 2. We did go to the Cat5 cabling. So now I'm able to hook up all these systems into a network. So having switches at each one of these presses and having all come to a server, much easier, much cheaper, much faster data. So I got rid of all the RS-232 cables. Cabling now entailed linking up to a general server. I talked about that, and then got obviously all the upgrades from the DiPro 1500 and the SmartPack to the SmartPack 2. Positive points, direct cabling with the Cat5. Data retrieve real time. If something was being done from tool changes or part counts or any of that nature, it was right there. And data with live information available to all computer stations. So that was another thing I implemented. Again, I go back to my original slide. You can't manage what you can't measure. It's good that I know the data, but I need the plant to know the data. So that was the beginning of the journey of starting to make sure that everybody knew about it. And that's when we started implementing computers at everybody's workstation, front office, toolmaker benches, press operators, quality room. I even went as crazy as there's 60-inch screen TVs all over the place. So tool room has multiple ones, quality labs, every one of them has it. I want everybody to know what the status of each one of these machines are at all times, because you want to be reacted to right away. We're all responsible for this. And then came the standard reporting that was programmed to the software. So instead of me taking the data, downloading it to Excel and have my templates already created and boom, off I went, now I have already pre-made reports. And I note the OEE, again, mentioned by Frexplo, it's still today the most important report that we have today. It drives our business, drives it. And I'm gonna get to details on that and how I customized it with Wintrust to really flag our worst performers, not by your OEE score, but on other metrics, which we'll get into. And again, other reports, including trendings of speed, and tonnage monitors, uptime, production summaries, all those we use today. Negatives, again, just limited to the presses. And as we got more and more into additional equipment, that became a problem, but Wintrust identified that with the next significant software upgrade, and that's Shop Floor Connect. So this is the latest that they have today, and it's compatible with the SmartPack 1, 2, and the SMI units, all of them that have the Cat5 options. So some additional upgrades, but we did have to buy the SMI 2s for newer press equipment, most notably the servo machines. Now, we have 2 servos, but that was before they did the SmartPack Pro. But there were pieces of equipment, or if you buy Minsters and Bruters right now, they actually have their own software system that controls these presses. So that way you have to use a little box there just to keep that data coming in. Positive points, expansion of the types of equipment the software can monitor with the flexibility of different hardware interfaces that can be integrated. I got a little robot over there. We had 0 robots in 2017. We now have 42. And all of them All of them are hooked up to this system. Additional standard reporting added, which included tool tracking capabilities. So availability, a status of tooling, and life of the tooling tracked. This is what we use to make sure to see where our die statuses are. I don't need to call the plant manager to find out if the die is ready, not ready, or whatever. When that tool is done, the operator is responsible from switching it from active to down, no matter what. Even if it works, no matter what. It's the tool maker's responsibility once he gets it into the tool room to check it out and then flip it back to on, or then there's an obsolete button, but it's all interfaced. Trying to call people and page people to figure things out, non-value add work. Let the system talk to you rather than go find the data. Again, another power of the internet and just the information data flow. Scheduling capabilities available on the software as well. So we go ahead and schedule all of our tools right onto the SmartPack and just download those right there. So the operator, when he goes uploads a tool, he's not searching for the tool. He knows exactly what tool he's gonna run, how many pieces he's gonna run, and what order we're gonna run it in. Multiple sites now can be consolidated and managed under one system. I had mentioned that we had 4 facilities. 3 facilities out of the 4 is manufacturing facilities. I see every single machine on all those facilities. It's somewhat of a negative because I do get sometimes I get complaints that I don't walk the floor much because I was walking the floor constantly. But quite frankly, I can run almost everything now right out of my desk because the information's right at my fingertips. Non-excuse, I still should interact more with the employees, and I admit that. But having this much data smacking your face and working on it, it's sometimes you get trapped in that and you get all this reporting and you just react to it and you send all these emails and set up meetings and do all these things. You lose track of time. So I do make it a point now, I have it on my calendar to walk the floor an hour a day, just so it reminds me just to do that and show my face around. But it's somewhat of a negative. Emailing capabilities. Why do I mention that? One of the coolest things I think about the SmartPack 2 and the Shop Floor Connect is the emailing capabilities. I had set up on all the downtime reasons, you can have email triggers. And I set up group emails. So for instance, we're setting up a coil. You got to feed a coil through a press, depending on the size of the press and how many stations are in a die, but if it's going over 30 minutes, you got a problem, typically. If I see a coil change longer than 30 minutes, email immediately. Managers, myself, tells you what press, the downtime reason, how long, what the hell's going on. People rush to the machine, find out what's going on. And I've set that up on a variety of different parameters of downtime reasons. They're all trigger points. And they're all set up in group emails to specific people, depending on who should be attacking what versus with these downtime reasons. Very powerful tool. Negative points, I'm still looking to try to integrate the data that we're collecting and putting into our ERP system. I am looking into upgrade our ERP system now so that they could talk to one another. They're still independent, but still, it will get there. I think the next software system that we are implementing right now, it's called Made to Manage. It's going to go live January 1st. It is going to be doing a lot of integration, getting live data so that I'm going to start condensing more and more our software systems down to one. Here's some of the reporting that we have. I'm going to dive more into the OEE reporting that we customize here in a few slides, but here's an example of our press monitoring system. Every single room in that company has that monitor showing all those machines. If it ain't green, we ain't paying the bills. And that's the philosophy. But again, going back to my dad said, you can't manage what you can't measure. Knowing that data and talking to the people and doing the Gemba walks, somebody had mentioned earlier about, and I'm going to talk about our meetings, but, do we involve the employees? Absolutely. Those are where the answers are at. I don't have the answer sitting in my front office. They have it. And so we do our daily meetings, and I'll go through the reports that we show with them, but we target it, and those employees tell us where the issues they have, what suggestions they have, solutions that they can offer. But without knowing that information, Flexpol mentioned that one of the presses was running only 5%. I mean, this data will tell you that right away. And you can very easily walk by machines and not notice that, but not when this is smacking you in the face. If you don't see green, there's a problem. So the outcome, the ability to manage the production of all equipment measured is increasingly significant, right? Is increased significantly. Let's start from the beginning, right? Clipboard. Now I got my data, I'm processing my data, and reports are being all automated. Data collected manually is now electronic. Downtime, timing parameters are set in which any downtime reason that goes beyond the time allowed, team members are instantly emailed. Talked about that earlier. Data and reporting is accessible to all employees. So again, everybody has a computer. Everybody. Tool makers, press operators, quality people, all this is loaded on their machines. Key metrics that were identified by management are now being reported to all responsible employees. And I have these reports going out per shift, per day, per week, per month. Right when the shift ends, boom, I got a report at 3 in the morning for my second shift. I got it at 3 o'clock in the afternoon after my first shift's done. And we attack it. Those reports are brought to the whole entire department. We have a quick 15-minute meeting. If certain metrics are not met, hey, John Smith, how come you only ran 40% OEE today? Well, Aaron, I had this problem, that problem, that problem. And it's remarkable what some of the issues that they have are so simple, but it never got up to the manager or the front office. Like, for instance, standardizing your tool crib to set up your tools. Well, I'm missing an 1/8-inch wrench or whatever. Well, what have you been doing this entire time? Well, I have to go to this machine, find that. I got to talk to Joe and get this. I mean, that ended real quick. But again, that information doesn't travel up. And unless you figure that out and find it from the data, challenge them and involve them, none of that stuff will come to surface. So yeah, I was talking about just with the Gemba and the concepts. It's real important to make sure that your employees are involved in this journey because they're being measured. Now they have accountability. And then you involve them in the journey to improve their numbers, because if you cut them out, they're not motivated. Now we're going to get to the OEEs. It's the most important report that I think that we all should be monitoring, just from a capacity standpoint, performance standpoint, just knowing your utilization. The report. So the most effective report we have, reporting a summarize of all programs run within the respective department, and then the event logs are vital within the operation. Having multiple shifts at play, it is key to understand what occurred and when and by who. Solutions cannot be determined without first identifying the root cause. Event logs do not lie. Cannot manipulate them. Here is one of my reports that I did for the month of just this last September. Now, typically, everybody will be focusing on the OEE, and my OEEs are all over the place. And right away, you would just say, wow, this is the job you need to attack. It only ran 2%. Boy, this thing ran great, 250%. I don't look at it that way, though. We sort it by unplanned downtime hours. Right? Your press is about $150 an hour, depending on the press. Multiply by that every month. So even though we did 67%, decent, this is the number. Now, what is within that number? Again, part of the other presentation, the Pareto analysis, you look at all that. So when I actually, this was sorted by the way, I forgot to mention it, this was sorted by tool number. That number just happened to be at the top, but this was by tool number in order. I sorted by unplanned downtime. This was my worst running job. At 78%, it's a good OEE. We're hitting this job. I had 94 hours of downtime on that press, unacceptable. Versus look at down there, 215%. I had 9 hours of downtime, but that's what people would be focusing. But I want to know that top line number. And this is recent data, not shy about this. This is from last month. So, what is that 94 hours comprised of? Click it, boom, all automated. It's not on a clipboard. By downtime minutes, and right away, tool maintenance. And the in-process inspection is correlated with the tool maintenance. I got a tooling problem. Boom, immediate pit crew, die makers, and engineers. I would tell you, you know, back when I started early on, when I was in charge of that department, it was like die makers and their black magic. But I looked at it as, no, you're putting Band-Aids on a problem. Engineer it out. Engineer it out. And that's what we did. So we have designated teams that hit these things. So by the time I analyze this next month or next quarter, that top line drops down to mid-level or down level. And by the way, that's just for die makers. You know, when I came into the company, like I mentioned, 2000, two engineers, my dad and I. Today we have 15 or 16 of them. I have 2 process engineers just in the plant alone. All engineers, not tool makers, didn't go to the TMA and learn and do die design. Guys that are just assigned to do all improvements outside of the die. Derailers, Kanban systems, 5S, material flow. That's part of your downtime. You invest in that, you cut that down. Here's an example of an event log. Gives you a timestamp by the second. Whether sensors were disabled, you know, that was another one of those. Remember, this is just an example, but whether you're running it on or off or not, whether it's running, coil changes, downtime, it tells you everything and it compiles it all into a Pareto analysis with full charts. But if you really want to find out what John Smith's doing, I could find out. I don't have to call him. Go right on the computer and check it out. Outcome. The key we report compiled and reviewed is OEE. So the tool tracking modules, the tool tracker module is closely monitored and reacted to the based on life of tooling. Preventive maintenance prevents reactive maintenance, which could lead to significant downtime of the machine. I'm gonna get into the tool maintenance in a minute. All tooling records are preventative maintenance tickets went from written records within the production logs to all managed through another software system. I've got another software system now where we're going paperless, and that's all part of this internet journey and all part of like just data collection. All my tool data is all on software systems. Every single ticket, preventive maintenance, everything. If there's an issue that the press operator sees in a die, he's not calling die maker John Smith. He's running a ticket in the computer system and it goes right to them, all tracked. Getting back to Shop Floor Connect, here's an example of the tool tracker. So when we quote jobs, as do many of you guys, I would imagine, you kind of figure, okay, you're running this material, you're going to use this type of tool steel and plating or whatever, so you're going to have some type of die maintenance where so many strokes and you got to sharpen it. This tracks it. We'll put in there the preset, like this particular tool, tool number 1, we figure 7 million hits. If it's within 10%, automatically we're lighting up yellow. Tool makers are always looking at this and saying, we're within die life here. If it's red, we went over. When we set up a job in the project team up front, we start off with what we preset, what we quoted. But I gave access to the tool makers now to adjust their presets if they perform better or worse, just so that they can get ahead of the game here and figure this all out. All automated. I get to see this right on my screen and so does everybody else. So again, the OE scores provided a breakdown summary by department. The monthly reports are compiled and uploaded into our monthly OE reporting, reviewing the last 12 months by department. I have those charts up. Everybody knows I've got goals and based on trend lines of what our OE percentages are and the uptime hours and the downtime hours and all the operators and all of the managers know those goals. And we look at the last 12 months of data. If I achieve my data 3 consecutive months, boom, 10% uptick in our goal. Keep pushing the limit. So the uptime and downtime hours are tracked by month, and although the OE score is important to measure and monitor, Weagle attacks the programs with the most downtime hours. I talked about that earlier. As programs with high downtime hours and low OE scores are analyzed, a breakdown of the downtime hours is further studied, and then a pit crew is sent out and hitting them. Results. The ability to manage what you can measure is the key to success. I took my dad's quote and I ran with it. Doing it for 20 years now. We were way ahead of the curve when it came to this. Empowering the employees to take real-time reports and the ability to dive into the data, knowing set goals gives them the motivation to achieve what the company sets out to accomplish. Sure, I have departmental goals if they're reached. I have luncheons, parties, gift cards, all good things. But at the end of the day, somebody walks into that door and just gonna flip on a machine and makes whatever parts, and it's not being analyzed, not being tracked, you're not being, held accountable. Unless they know they're being held accountable, they have goals to be set, which was in the prior presentation. When goals were set, everybody was just competing against each other. That's exactly what's going on in our facility as well. We've seen a 30% increase in OE scores just from 2019. I could tell you going back way earlier, just the utilization. I mean, my dad loves to buy presses, loves it. But every time I was going home in the 2000s, half of them were running, and then when I went home at night, and then basically 2 were running. No, we're here to make money. We're here to have press utilization. So I was determined to make sure that we don't buy any more equipment, we don't expand. Let's utilize what we have, get that uptime up before we make those capital investments. So just in 2019, it's 30%. I can tell you it's been a lot better than that going back to the 2000s. You can see your uptime machine hours increased by 64%. That's from 2019 as well. My brother hates me for it because he loves buying Bruters and Minsters, but I put a stop to that. Then problem solving became easier with true recorded data points available real time. Can't manage what you can't measure. Conclusion. Came into the company, we had maybe 20 some customers, and I would say 16, 18 of them were all within a 100-mile radius. We're competing against local guys around here. Global today. It's global today. We all know that. We got to compete against the cheap labor in China and whatever's going on in Mexico. I mean, we just have to be competitive globally. So in order to do that, you got 2 options. Option A, raise your prices. Now, how many of you are going to get away with that? Maybe this year with inflationary points, but they're normally asking for 3% downs every year. You got to cut costs. It's easy to whack people, or you attack your problems. But you don't know what to attack unless you have to identify what it is, and that technology and extracting that data will get you there. So drive down costs and ability to manage your business through the metrics identified using data compiled real time is one of the many key components to a successful manufacturing company. Questions?
Questions for Aaron? I might have to.
Yes, sir.
Yep.
Hey, good morning, Aaron.
Morning.
Yeah, very nice presentation. Your unplanned downtime, you showed some details behind that on slide, I think 24. How are you measuring, or what's detecting like things you see within the die, like slugs? It was mentioned on there. Is there a sensor or somebody inputting that data?
Both.
Okay.
Both. So in Shop Floor Connect, there are a total available 32 slots of downtime reasons you can program into the computer. 16 standard, 16 custom. For presses specifically, I do both. How do I do both? One, I put general slugs. If the operator is having slugging issues, part of the nice thing about Shop Floor Connect is you can force them to give you a reason. So I program on every single machine that if the machine is down for longer than 5 minutes, you cannot turn that machine on unless you give me a downtime reason. It's forced. And so if it's slugging and it's not tripped by a sensor, they put slugs. But that gets into my second point. It's the sensors. We have, I mean, it's like driving a car without any, like a speedometer and gas gauge. You don't want to drive, you don't want to be running a die without any sensors. We lead in technology on the sensors, and I have stripper sensors throughout all the dies, monitoring them with micro scans, and I'm detecting the stripper gap between the die block and the stripper to determine if we have slugs. And that will determine also whether or not I have slugs or not. And more importantly, not only do I have slugs, which sensor trips so I know exactly where in the die I'm having issues with, and I could study those particular stations in order to solve those problems with the toolmaker. So it's more involved than just naming slugs. You're welcome.
Question back here. So much easier to be on this side of it. You mentioned earlier that you have emails automatically generated for coil changes taking 30 minutes or longer, right? And you have a group of folks that go out to see what's going on. What does that look like on your end, and what does it look like on the operator end? Are they just getting bum rushed with 30 people like, hey, what are you doing? What does that look like on both ends?
So it was initially because I got too aggressive. I had tighter windows, and we were just getting inundated by emails, and it wasn't realistic. So we had to take a step back and take a look at what realistically do we want to go ahead and attack those issues by more reliable, allowable times. So we dialed that all down, while at the same time, the operator saw us on the floor with them, meeting with them on every shift, meeting with them every day, going over the numbers. And not only were we meeting with them, one of the things that we were meeting with is not only is the operators, it's the department head, it's the plant manager, and it's the process engineer. And the process engineer is important in this whole thing because they acted as not only solving problems outside of die, but a scriber, a secretary. Because the last thing you want to see is your operators giving this data and then everybody's nodding, yeah, I'll do it, and then nothing happens. So we took down every single suggestion, good or bad. And the first thing the process engineer would do would document all of them, basically making an action item list. So we would list out every single action item, write down what the suggestion was, who's assigned to that action item, what the due date was, and whether it was complete or not. And that was posted within that hour onto the departmental board to show the operators what tasks that were described in those meetings and even outside the meetings, who assigned it, and whether we're going to attack it or not, and whether it was closed or not. And if we did anything to it, or most of the time we didn't, or not most of the time, we took a lot of those suggestions and implemented it. So everybody had input. And that creates the environment that you want and the culture that you want, that everybody's involved in this and we're driving towards one goal.
Aaron, thanks again for the presentation. Awesome about what you're doing with the winter side of it. And if you haven't had a chance to have a tour of the facility, it's unbelievable. Him and the family have done an excellent job over the years, and now with the siblings taking it to the next step. Besides the winter side, he's also doing a lot of stuff in automation side. Like, can you kind of comment on what you're doing, like robots and cobots, and how many you had like 5 years ago to now, how many you have now? So you're just not investing here. Obviously, it's other parts of the plant, but we talked about a little bit about robots and cobots yesterday, and just want to kind of have you kind of
Sure. So, I realized real quick when I became president that if I was really narrow-minded with just being a stamper, I was really boxing myself in a corner from growth. And so we challenged our sales and engineering team to take it to the next level and go after more capabilities and be good at it, and including not only different capabilities, but automating a lot of it. So in the last 6 years, like I had mentioned earlier, we went from 0 robots to 42. And it's just a matter of learning that automation, implementing into your press operation. We have automatic packouts in our presses. We have transfer systems, instead of a progressive die, having transfer dies, transferring stuff from station to station, but those are not automated with a robot, but you do have robots, putting them into the tool and then taking them out of the tool, and then introducing them into an assembly line. So we've incorporated that. Our welding capabilities. Now, typically when I see most of the companies I toured within the PMA groups, I've seen a lot of these, big steel brackets, and you're doing welding with nuts and all that. We're taking electronic components like aluminum, copper. We're getting to that part of the industry and doing a lot of different welding operations where everything is automated within a custom machine. I'm right in the middle of it's patent pending, but we've incorporated all that to get rid of. I don't say get rid of labor, because I could tell you all the 42 robots that we've implemented, we've laid off 0 people. That's kind of a misdemeanor about automation, is that you get rid of labor. We actually helped us grow, and we redeployed people to different positions, or better yet, which I love to see even more, those people that were on the line that we put robots instead, we up-trained them. Gave them the opportunity, up-trained them. Now they know how to run the robots and service them and do all that stuff. So you have all that in there. All of our assembly work now, I did 0 assembly work 5 years ago, but we realized that we're not in a low-cost country. We're in the United States, so unless I'm in Mexico, but Mexico, anybody, you're all human beings, right? I mean, you still need to eat, you still need to take breaks, you still need to go to the bathroom, you still got to take vacation, you still got to get sick. Robots don't happen. That doesn't happen to robots. Not at all. So we're running around the clock with just having people monitoring them, and we've upskilled people. We brought on additional high-end people to get the robots working right, and it's just been a complete success with the automation. And there's not a program that we bring on board today that I don't strongly consider automating it, especially if you got mid to high level volumes involved.
Okay, anything else for Aaron? Excellent. Thank you so much,
Okay,
Aaron. Good presentation.
thank you.
So we've got a break programmed in right now. I've got it set at a half an hour, but I'm thinking we could maybe change that to 15 or 20 minutes. Everybody okay with maybe a 20-minute break? So let's come back promptly at 5 minutes past the hour. So I think there's some drinks and snacks down here and upstairs. Thank you. All right, so you want to go at it?
Yeah, I didn't take them out. Actually, no, that's that out and easy peasy. There we go.
Just one slide?
Just one slide.
Okay.
So I have added, obviously we have our platform and stuff like that. Since I'm talking about like some of the things like the IoT protocols and stuff like that, I've included some things of like, we have a technical white paper that's available.
Okay.
So the links there, I don't know if these people get the presentations.
They do. They do. So they'll be able to click on the
So
link.
they can click on the link if they want it, and then, at the end, got, basically talking about, how do I start? How do we start with IoT? It's that, the idea is having those talking sensors, the IO-Link sensors, which, is what John Daly was talking about. It's John Daly.
It is.
The guy from Machine Metrics.
Yes.
Yeah.
He used to be
Funny
a
name.
golfer.
Funny name in Chicago. Yeah.
Well, the funniest part is we had a Ben Hogan here earlier.
No way.
Yesterday. And then we had, there's another,
And a Roger Federer.
no, but there was another sports
Oh, that's hilarious.
name. So there was 3 of them on our badge list. Yeah, that's hilarious.
That's too bad my name isn't Bradley Beal, because then I could add in your
I
basketball
think
player.
maybe that's who we included.
Yeah, okay.
We included you.
It's
That's
Bradley
what it
Beal.
was. Yeah, yeah.
Or not Bradley, but as
I'm
you know.
Bradley,
but-
you're
yeah.
Bradford.
But yeah, so anyway.
Okay, we're good.
Yeah, it's always so funny because people are like, oh my gosh, Bradley Beal. Da, da, da.
I know, right? Should I introduce you as
No,
Bradley Beal?
here's the, no. Here's what's funny is my first thing was like, I said, who? Like, I have no idea who that is. And all of a sudden they're like, hey, watch this. Yeah. So.
Yeah, that's good. When we saw your, that you were going to speak, we were talking about it. That's what Bradley Beal, the basketball player,
That. Is there a laser pointer element to that? Well, there is, but it works.
Okay.
But it doesn't work at the screen. Whatever that is. Sorry. But you can walk up. No, that's it.
All right, we're going to go ahead and get started again. Thanks for coming back so promptly. So now we're going to turn our attention to sensor technology and then condition monitoring. So our first presentation now is on sensor technology to drive home kind of everything that we've heard up to this point, including what Aaron just explained. And for the talk on sensors for IoT, we welcome Brad Beal. Brad is the manager of Pepperell Fuchs's Global IIoT Solutions Group, which develops the sensor solutions for automation applications. For the past 4 years, Brad's been managing IIoT initiatives with Pepperell Fuchs globally, focused on sensor-to-cloud data connectivity. He's got 25 years of industrial communication expertise, so please welcome Brad Beal.
Thank you. Appreciate it, Brad. We're all named Brad here, so. Anyway, thank you very much. Really appreciate it. Appreciate the invitation. I was actually the second invitee from PMA, so the first invitee from Pepperell Fuchs was Dr. Helge Hornes. He's an esteemed PhD physicist, and as you'll probably notice, I am neither a doctor nor a physicist. So what I do bring to the conversation here is an element of what IoT is as far as what Industry 4.0 can do. The key that you've been hearing a lot this week has been all about metrics, OEE, condition monitoring, and a lot of the software systems that can deliver it, and also, of course, the machine examples that you have. So where I came from in the industry and where I got my years of experience in industrial Ethernet communication, I was formerly president of Comtrol Corporation. We, as far as a company, invented the first multi-port serial adapter many moons ago when I think Aaron mentioned wiring serial communication cables to all of his machines. That was, likely going back to a server with a rocket port, multi-port serial adapter or type of equipment for that. So fast forward now into further on into the industrial Ethernet age. I started out in the industrial communication space, creating gateways for industrial Ethernet like Siemens Profinet, and of course, Rockwell's Ethernet IP and Modbus TCP. So what we're talking about here today is all about IoT and sensor connectivity. John Daly from Machine Metrics just cursorily mentioned it, but one of the things that he mentioned is something near and dear to my heart. So if you look at Comtrol as a serial communication company, as you probably know, there's fewer and fewer serial devices out there in the world. As IO-Link came along as a sensor communication connectivity standard, all the different sensor manufacturers from around the world, I know that we're talking about machines here, but inside the machines, as some of the other speakers were discussing, they were talking about the fact that every machine's got to have a sensor in it. And so with that, sensor communication, the new standard, effectively became like a new serial communication standard for sensors. So digital and analog sensors, we're starting to add in and still are. Every year, there's another dozen companies that are basically becoming members and coming out with new IO-Link connectivity products. So what we're going to be talking about here today is really what is IoT and sensor connectivity within a context of IO-Link? What does the IoT architecture look like? How the applications can be used for predictive maintenance and condition monitoring with the sensor communication, and essentially what you can do for different examples here. One of the things that show up here on the screen is a tutorial or a white paper, because a lot of the things that you've seen, particularly with the software companies, they're sharing all sorts of information about IoT protocols. Some of those IoT protocols they mention as, they're like standard normal things we deal with every day. To a lot of people, they're not normal standards that people talk about every day. And so we have a white paper here talking all about what a RESTful interface is like, what it may also be termed as a REST API, how you also may have MQTT, what is MQTT, et cetera, OPC UA, and AMQP. So looking at what the architecture looks like for IoT and Industry 4.0, what we've done, and actually as president of Comtrol before Pepperell & Fuchs bought our company, we had created the first industry's first IO gateway, or basically IO block that incorporated IoT protocols directly into the block. So you now have a way of taking the data directly from the sensor in your machine, bringing that up into the cloud. Now, okay, that's nice and aspirational. Do you really want to take all your data directly from the machine and put it in the cloud? The answer is no. It's going to cost, you're going to give Jeff Bezos even more money that he doesn't need. So what you're going to want to do is you can provision the data, but the whole point is the data is available. So what we were able to do is recognizing that not every PLC needs to send out every bit of data that's available in the sensor. But the point is, the sensor has about 50 to 200 different attributes of information that is outside of your process data. Okay, so maybe the PLC is going to ask for alarm data or event-driven data, but there's a lot of other information that I'm going to get into later in the presentation that's all about things that are about the sensor, that you can use that data, those attributes of the sensor information, to pull out valuable information for predictive maintenance, for condition monitoring, and things like that. So you want to know more about the operation. What is that sensor telling you? I think the gentleman, Aaron, was talking about going over to the specific die location and knowing where it is, and they're using the sensor information to find that. What they're not finding out is really why that was happening, or even before that event happened, that it was going to happen. And there's a lot about IO-Link and the sensors that Pepperl & Fuchs provides, as well as all the other manufacturers out there as well, that they can give you additional information. The key for us is by embedding the IoT protocols inside the IO block, you now have the ability of taking that, they're called index service data units, ISDUs. You can take that ISDU information and send it to a software system that can actually do something with that data. You do not want that data going into the PLC. And you're probably not going to be able to get the PLC programmer to reprogram their programs, which is reliable and repeatable. You're not going to be able to get them to reprogram the PLCs just because you want to go and find out about RFID antenna attenuation or laser gain information. So what we're talking about here is, again, we can provide, outside of the PLC, we can provide simultaneous data collection to any software package that will collect OPCOA, MQTT, or Modbus TCP information. Your PDI and PDO can continue to go to the PLC, or you can also send that along to your upper-level software system. And where this really gives you a great benefit is, as you were talking about with Machine Metrics or Plex or some of these other systems, starting small, getting a collection of sensors that you know you want to use on a particular machine and start doing something with that right away. We give you the capability of doing that with almost a variety of endless software packages that you might choose. So you get to choose your best of breed software application. You're not going to be locked in because, again, they're using industry standard IoT protocols, such as the ones I've mentioned. But here's a whole list of a lot of different software applications and software packages that work very well. What we're doing at Pepperl & Fuchs, and actually my group, is actually designing an entire cloud-based system with AWS, tied in with GE Digital as a historian with the Predix AWS cloud instance. And we're showing that on a machine at the SPS show in Nuremberg, basically showing how you can pull data, vibration data. It's tied to a rotary encoder and a motor driving machine. Basically, it's a product that we have that's also IO-Link. You can get all the information from those sensors and then basically store that data in the AWS instance. So looking at what are some of the key things that you want to do. I wrote this presentation before I saw all the other presentations, and so here I'm talking about OEE, predictive maintenance, and condition monitoring, and you've heard all about it all day, today and yesterday, so I'm not going to get too into that. But the idea is you're able to show, Pepperl & Fuchs obviously is heavily invested in automotive applications as well as logistics. We are providing a huge range of inductive sensors, so a lot of your machines may have a Pepperl & Fuchs inductive sensor in there for doing die and tool handling, et cetera. But these are all these different industries. Everybody wants to know how they can get more access to more data of what's going on to give them situational awareness of what's going on in their facility. Whether it's an Amazon logistics center or GM press room, you have all sorts of things that are going on all day long. You're producing products, things are moving through. You want to know without having to go talk to an operator what's going on in their machine. And so the sensors will actually be able to tell you that. A little bit about OPC-UA, why it's important. This is kind of a deep dive into OPC-UA. One of the key things is as you look at the software applications you're using that you're planning to use, OPC-UA gives you an entire knowledge of what's connected into the software system. It's as simple as typing in the IP address of our I/O block, and you immediately see a data tree of all your sensors that are connected to it. And not just the data tree of the sensors, but also how they're configured and their settings. And so one of the things that we really highlight is it's not just about getting the system set up and configured, it's staying with that whole system through its lifetime. And so a lot of that lifetime is going to be involved with configuring the sensor, but also reconfiguring a sensor. If the sensor gets hit by some sort of machine, gets knocked offline for any particular reason, or goes bad, the IO Link standard and the communication setup that you have through our connectivity gives you the ability to automatically reconfigure the sensor in 15 seconds because all the settings for your sensors are stored inside of the IO block. The IO blocks, it's known as an IO Link master. The IO Link master settings are all stored in a software file that your software application, whether it be Plex or Machine Metrics or some other instance, you can download a new configuration file to the new connectivity block and the sensors and basically reset that whole setup with all the original settings that they were operating with. So again, tying in between SCADA systems, MES systems, they all want access to this data. And OPC-UA, is, along with MQTT, gives you a way of doing a publish and subscribe architecture to be able to let them ask for that data. So when you're architecting an application, it's really key to see what is the data that I want. Do you want data from every single sensor coming out of the machine, or are there specific sensors in the machine that you want to be tracking and looking at to give you some sort of idea of what is the health of your system at that point in time? So again, OPC-UA allows, and MQTT allows your PNF sensor data or whatever sensor you may have. Again, we make a lot of sensors. We don't make every sensor. The key is the connectivity is the core part of your operation to be able to get access to the data. We support connections to almost every sensor out there, but the key is to be able to get access to that sensor data directly on the machine. So this is a good example. One of the things that I really talk a lot about with different people, and particularly with customers, we're doing a large application with John Deere right now globally, is discussing what is the data contextualization or data norming. I had asked a question of that of a lot of people, and that is absolutely critical because your temperature data value is going to be much different than your pressure data value, which is going to be different than your data values for vibration. As you have data coming up through MQTT, it all comes in as data. So it's absolutely critical that you have a pathway. We really highlight, and this really gets me out of what I do in my role, but my role is really educating customers on how they can get the total solution working. And the key is, in this case, we have an example of something called HiByte. Actually, I know everybody seems to talk about Kepware here. A lot of the former, including the former owner of Kepware, all moved out and moved away from PTC and started up HiByte. And so this is a lot of former Kepware people. But their core operation is to create a unified namespace, which lets you tie all your data into one area. It norms the data, gives it all the same data contextualization, and then shares that with all your other applications. So I know we've had people talking about WMS, MES, SCADA, and ERP systems, as well as, of course, custom applications. But the key critical point is, as you're taking data in from your sensors, what is that sensor data value? It's not just sensor A, B, and C. It's the inductive sensor on this tool. It's the temperature sensor on this machine. It's the vibration sensor. And you want different applications to get immediate access to some of that data because perhaps some of the alarms that are coming off of one particular sensor, whether it's an RFID for badge in access, or maybe it's a vibration sensor that's going out of whack. There's certain software applications that want to get access to that data right away. It's not something you want to look on a monthly report when you have a problem that happened 12 days before that. So what we do is, again, through Opus UA and MQTT, we give the ability to share that data. The data populates into the HiByte system, connects. Basically, it has a configuration. We're working on an automatic configuration for so that you can just plug it in and it already knows the data values coming from the Peppermint Fuchs IO Link Master. But then it populates in your software system. At that point, once it goes into the UNS shares with all the different software applications. And so what you have is sharing common data to all the different applications around the what you're using and analyzing in your plant. Talking about the IoT architecture, this is something that people get bored with seeing because they see it so often, but this is kind of the hierarchy of some of the systems. But what's interesting is as you start looking at why these different applications want the data, you look at different ways of how you can share the data, because everybody traditionally right now, and we talk about this in the legacy system, if you're sharing data between different applications, but then suddenly you go into a pub/sub methodology or architecture, then you don't have to just trust this linear process of it goes from the PLC to the SCADA system to the MES system. You can now share the data simultaneously with the different applications. Again, like you may be having something go and do an inspection on a particular asset, and so the MES can then drive some of the different requirements, whether it's reordering parts from the ERP system, or basically scheduling some maintenance for a particular machine in an operation. We're getting crazy on the charts here, but this is actually a model that is the reason I want to highlight this is its value to your operation. Again, we're talking about starting small. Once you start small and it's been sitting on the plant floor for a year or two or three, you really haven't started when you started small. You weren't thinking about life cycle management. And so one of the key things, the Germans love their protocols and they love their models. And one of these is they already have a model for the Industry 4.0 as far as life cycle management. And so one of the things that they share is how you can actually add in extra control within your sensors to be able to let your sensors drive basically the next sensor that needs to be purchased to keep that operation running. So it's one thing to put a sensor on your machine, but if that sensor fails forever, for whatever reason, in 5-10 years, you go to the market and you don't know if that same sensor lives there, is available on the market. And so you have to go and buy another sensor. How do you actually help your operators find the sensor that has the same data types, provides the same capabilities? And so there's something called what we like to call digital nameplate. But digital nameplate gives you the ability of managing your life cycle of your sensors and the equipment that's inside your machines. And so it's something that allows you to go and find that it'll suggest that next sensor that has the same data types that your sensor that had or supports that was running in your machine. So looking at the asset life cycle, how can you go and help keep your machine running? Because if a sensor goes down and you have to order a new sensor, what are you going to do if that new sensor is not available or doesn't operate the same way that your old sensor did? So there's a way of talking about in this maintenance usage is able to drive your ordering and even share the information with your ERP system to order new parts. Again, I was talking about the legacy architecture or indicating the legacy linear architecture. This is the old way of doing things, and this is probably the way most people are doing things right now. As you're looking into IoT Industry 4.0, I really would like to submit that you need to think about how you're sending data in a different way. So just doing the simple connect the sensors to the PLC, and the PLC is going to send me whatever data I need. That's not really the way things work anymore. You have a lot more options to be able to share the data. Still goes to the PLC. The PLC is still operating, but how do you go and drive the data metrics and the data analytics with really fine granular data that's available within your machine? How do you get that information up to your different software applications in the best manner? And I would submit that the PLC isn't the best way to send OPC UA data and different things like that. So what we are able to do is give you the opportunity to have your IoT applications communicating with the sensors and being able to see where you need to make moderate changes to your sensors if you're not getting correct reads, for example. So you can do things like automatic beam adjustment with IO-Link sensors. These are in an ultrasonic case, but in an inductive sensor, you would have the same ability at modifying the read range or the attenuation of the signal. So looking at vibration sensors, we're talking a lot about predictive maintenance and how vibration is important to monitor that in the machines. You look at these different wavelengths, et cetera. The core differences, and one of the things that you look at is machines is always vibrating. So the question is, when are you getting to the level where you should actually have some concern and you may actually need to be thinking about going and doing some maintenance on this? There's a lot of software applications. Again, this is an example from a company called IoTco. And you've got vibration analysis on a bunch of different axes, and you have the ability, your software has the ability of telling you when you're getting to a point where you're getting closer and closer to a failure or what would be a problem. And so you can actually go and use the predictive analytics to be able to go in and do maintenance at the right time or try to figure out what the problem is and then solve it before there's some catastrophic failure. Again, talking about sensors and how it applies to IoT here, read range on optical sensors, same thing. So when you have material coming in, whether it's a die coming in or parts being ejected out of a stamping machine, you want to be able to go and see as those things go by. You can also use them for parts count. One of the things that we do is you have the ability of taking the laser gain, and I'm going to get into that in a little bit more detail later. But again, with the IO-Link sensors, you have your process data, you have the configuration, you have your status and alarms, but then you also have excess gain read from the optical sensor. Again, that's not something that you're typically asking for. Your control element of the machine doesn't care about excess gain on your optical sensor. However, you can utilize the value of excess gain to be able to know more about your operation. And I'll show that here in a second. This is just, again, talking about the PLC and then moving to what we call multi-link, but it's a parallel path for your data. So, I apologize, this is back to digital nameplate. This gives you an example of the readability and being able to use it to order new parts here. So again, for the photoelectric, using the data with excess gain. Excess gain is used when you're getting the feedback from the sensor using a reflective plate. It's reading what your excess gain is. You can use that when you start seeing the excess gain line going down. That's an indication of something. Now, it doesn't mean that your machine's stopping. It doesn't mean that it's not counting it. It just means that it's using a lot more of the extra power to be able to get a good read. And so the value of getting that good read, obviously, if you stop reading the parts ejections or you're not reading the parts coming out of the machine or you're not seeing the dies come in, that's going to essentially stop the machine or stop the operation. Doesn't mean the machine doesn't work, just means that some of the sensors are having a problem. So what that's going to do is should trigger through your IoT application, you can use that ISDU data value to be able to go and do a maintenance check on it, whether it's cleaning the reflector or you have to clean the lens or checking some other alignment issue for the sensor. You have the same thing with check alignment, and then you're back to the regular laser gain information. You have a catastrophic issue here where you might actually have the sensor reflector knocked out of alignment because suddenly your laser gain dropped completely. So when you see that data value, that's, again, not something the PLC is ever going to detect. It doesn't even have the ability of pulling that data out of the sensor. However, you can have your IoT application request that data from the sensor and then populate that in your software application. Suddenly you go realign the sensor. Again, these things are simple adjustments. I think somebody was saying it takes 10 minutes to solve a problem that they didn't know they had. But this is a problem that you might not know is a problem inside the machine. But once you see that drop in laser gain, you can make the adjustment and realize that that problem is literally just the sensor got knocked by something, or maybe something hit the reflector and suddenly you're not getting that information. So again, using the data value that's available from the sensor in an IO-Link and IoT application to be able to drive good decisions within your software systems and then keep your maintenance of your machines running optimally. Here's another example again of your excess gain just dropping to a critical level, and then suddenly your output's zeroed out. So one of the things that you also have is for your distance to object, the object is affected. These are the diagnostic data things that are available. I'd like to move on quickly over to something more related to the vibration sensor. This is just output data. Okay, moving on to the vibration sensor, we actually have a new IO-Link vibration sensor that's available now on the market. Running on motors, fans, different machines, it's absolutely critical. So one of the key things is to look at, obviously, your wavelength analysis. As those things start trending up and you're seeing that there's more vibration, you can do with the software applications that we've heard about this week, you can do some sort of analytics on where the frequency is and what it's increasing to, and then suddenly realize, okay, we think that there's going to be a problem at this point. Maybe it's next week, maybe it's in 3 hours, but it gives you the opportunity to go do a maintenance check. Whether it's going to be critical or not depends on when you might do that maintenance. But gives you the opportunity to hit it before it hits an alarm level and hit it before there's some sort of damage that occurs. Again, here's the opportunity. You make the check, you make the you realign it, and suddenly it's in a better operation stage. One of the things too is as you're in your analytics, you want to be able to have your software realize how often these things are happening as well. It's one thing to go and say we took care of an event. It's another thing to say, okay, if you look at, and this is where a data historian comes in, and this is where your AI comes in with your analyzing the data. If you're having situations that happen, again, I was in serial control for decades, and you have problems that happen and you don't know why they're happening, and you're trying to figure out what might have been happening on the machine, or in this case, it was 4 a.m. going through a tunnel and all the RFID pole tracking systems stopped working, and it only happened every once in a while, but it always happened at the same time, and we were able to find that it was something going on the roadway that was causing it to go out. Not a big issue, somebody lost some toll, but companies making the money from it don't appreciate it when their toll antennas go out. But in the machine world, for you guys with stamping machines, et cetera, you want to do a trend analysis on some of your alarms or some of the problems and some of the maintenance that are happening. So you have the ability with the sensor data going into your software applications using these IoT protocols to actually do some of that long-range trend analysis. How often are these things happening? How can we reduce the maintenance that's necessary due to vibration or some of those different things? So it's not only just letting you find out more about your machine, it lets you find out more about your operation and how to especially tune your machines and the sensors to eliminate those problems. And so 4 takeaways that I'd like to talk about here, just in Sensoric 4.0, that's our marketing lingo for Industry 4.0. But 4 takeaways that we have is modern sensors are allowing the separation of control and diagnostics. So it's one thing to have control of your operation. That's the most important thing. But diagnostics and analytics is a whole separate thing that has nothing to do with control. And so what we try to do is give you the ability to do things simultaneously. Again, IoT and PLC protocols can work simultaneously, but letting your software applications that are tuned to figuring out problems and raising flags is one thing, but you need to also ensure the control application is moving along. IO-Link is the absolute core critical new standard. Why? Because it's bidirectional communication. And so it's letting your machine speak. It's giving your machines a voice. One of the things for your operation as software companies and partners come in is really asking about the protocols that they're supporting to make sure that you have the opportunity to not get locked in, but also to be able to go and find that multiple applications can use these protocols to give you more information on your plant floor and let you select the best of breed software or the best software for your operation. And then finally, give your machines a voice here. So how do you get started? It's one thing to say, okay, we know about sensors and software, that's great, but how do you actually get started? So what we did, and my team created what we call an IoT starter kit, and that gives you everything that you need outside of the software to get started. So you have a configuration guide that you just go to that QR code, and it gives you the configuration manual on how to set up everything with MQTT or OPC UA. And it also gives you an RFID tag, optical sensor. You can actually add an inductive sensor as well, and gives you the connectivity, cabling, Ethernet switch, and power supply that you need to get it all started up and put it on your machine. So essentially, if you want to get started with IoT, very easy to do that. And you have the protocols that are already natively built in to work with the software vendor that you choose to work with. And then it's happy days from there to start collecting the data and seeing what you can do with it. That's all I had. If there are any questions, I can answer them. It's getting late in the day.
Yeah, so IIoT is, I don't know, about 10 years old, maybe from your perspective, a little older. The sensors developed for IIoT are significantly different than other sensors that Pepperell Fuchs manufactures. The evolution in that technology, where is that?
Yeah, the evolution for us is like every new sensor that we're producing, we're always going to have a variant that is IO-Link enabled. And so it's, I can walk through that pain with everybody because I've been waiting for the vibration sensor to come out with IO-Link because, you know, it's been existing with analog for a long time, and we haven't been able to get the IO-Link information and software, and basically it's a different type of sensor because you can reconfigure it, et cetera. So as you see, Pepperell Fuchs may have, you know, 10,000 different sensors. A subset of those, maybe 5,000 or 6,000 of them actually support IO-Link. And so there's always different variants, whether it's ultrasonic, optical, et cetera, that are going to be supporting IO-Link. And it's the same thing with a lot of other companies as well. You know, I actually, as president of Comtrol, all the sensor companies were my customers. And so we were private labeling our IO-Link master to a lot of the different companies, IFM, Baumer, Datalogic, number of different companies. And so their interest in IO-Link is that it gave them more capability to offer a larger solution to their customers. And their customers were looking for more data. And so from my perspective, I still, you know, I work for Pepperell Fuchs, but I understand that it's a total solution, and Pepperell Fuchs doesn't make every sensor out there. So, you know, there's temperature sensors that are absolutely fantastic from a lot of different companies. They all come in IO-Link versions as well, whether it's Anderson Hauser, IFM, Balluff, or a number of other ones. So, thank you.
Thanks, Brad. All righty, coming down the home stretch, and I think a good dovetail to the talk on sensors then is an enabling technology for Industry 4.0 called condition monitoring. So to cover that topic, I'm pleased to introduce Joe Bartolamioli.
Perfect.
Is that pretty good?
Yeah.
I'm only going to say it once. A product specialist with the BrandCamp in-process monitor line at Marpos. And I want to thank Joe for switching presentation times with us. Appreciate that. So Joe's got 33 years of experience in the stamping and metal cutting industries, working with customers to provide sensor solutions for their forming processes. He also provides MES solutions that enable a direct link between production machines, their process monitoring systems or data collection terminals, and production management and ERP systems. So please welcome Joe.
Get that pointer? Hello and welcome. Since all these great presentations, I narrowed my presentation down to 3 slides. We'll make it quick. So, but now if anyone's familiar with Marpos, they're usually related to gauging, inspection systems. We also do monitoring systems. Marpos has been in the business for 70 years. They're in about 34 countries around the world, and they've acquired about 26 companies in the past 20 years. So they've been gradually acquiring companies, and in this process, they acquired the BrandCamp line of monitoring systems where we monitor the force. They're in the automotive, aerospace, medical industry, electronics, packaging. They're all involved with gauging and inspection systems. That's what the Marpos line does. Marpos itself is based out of Italy. Like I said, it started in 1952. BrandCamp started out of Germany in 1977, and we were acquired in 2013 by Marpos. We are out of Auburn Hills, Michigan. We have sales and service out of there. We also have sales and service out of Canada, as well as Mexico. So we're pretty well backed in all the different North American regions. The BrandCamp monitor. It's a little bit different process from what you were talking. We were talking about sensors before. We're looking more in-die sensors. We came from the cold forming industry. We have one of our companies that we purchased along the way deals with acoustic sensors. So we monitor everything in die process. So we're more looking in the dies of what's going on and trying to develop the signals of what's going on there. You put a monitor separate on the machine, and we put sensors in the tooling to see what's going on, and it's a repetitive action is what we're looking for. We're looking for a repeating force all the time. So this is normally an output. As the press is moving, we're getting an output of a curve, signature curve. What we do is we put an envelope around it. If there's anything that changes from that variation, then we can stop the machine or sort the part out. It shows an envelope of what's going on with the process. It's not a distance sensor where you're looking at a peak voltage. You're looking at the whole envelope of the curve of what's going on, the development of the tooling of what's going on. So that's where our background is. You can see a lot of the forces and the repetitive, and they can detect a lot of things of what is actually happening in the tooling. Here's some examples of what we pick up. I know slugs are what everyone does. Everyone deals with distance sensors on slugs. So the distance sensors are basically on each side of the tooling, and we have piezo sensors in the stripper plate that we put. So you can pick up the bending of the tooling. We only need one sensor in the tooling, and you don't have to adjust it. I know distance sensors, you have to adjust them up and down, and you have sensor engineers that adjust them and all that. This one, you put it in, and what we're picking up is the bending of the stripper plate. On a distance sensor, on the ends, if the stripper plate comes down, the tool bends, you're coming to the same distance if the slug is in the middle of the tool. Our sensor picks up on the bending, so we can see a lot more. You can see in the lower end, we have the can tops. We pick up on, sorry, small cracks in the can tops when they're producing can tops at, 800 parts per minute, they're pumping can tops through. And then we can look at them, and you don't really want to stop the machine sometimes on this process. So they have magnetic conveyors that go out, and it drops them as they're going out into a pot. So you can see we can keep the production running and have the problems ejected at the same time with very fine details picking up on. Now, mentioning conditioning monitoring, we want to see what really affects the machine itself. The machine itself, what affects it is the environment around, the temperature that a machine is in, the actually raw material. It could be the temperature of raw material. We've had effects where the process runs smoother when you have raw material that was outside of the plant. They brought it in first and let it adapt to the temperature and then put it into the machine. Because if they take it from the cold out, it's not running the same. It doesn't run. It's a cold material going in. So material hardness, if it's not consistent through it, it creates problems and creates force issues. Another thing is material feed. The feed rate, depending on the tooling, you might need a faster feed rate or slower feed rate. We can look at the feed rate. Lubrication. Lack of lubrication really affects it. The thicker lubrication, thinner lubrication, all that affects it. Even the misters. We have it where a mister would affect it by the forces going on, where we had the machine shutting down all the time, and it was happening every so many strokes. We looked into it, and you can't see anything going on. Well, it was thin material going through, so we cut the material out, and we looked, and it was a defect where it was concave. And what was happening was the mister was clogged, and every 10 strokes, it would make a blob on the plate, and the material would feed in, and it would hydraulically form a little concave metal in it. So it really affects the signal of what happened in the force. So everything kind of affects it. And we have here, it all affects the tooling. You can see the process curve up there. It looks like a strange curve, but the curve itself represents the forces in the tooling. The first little hump is the stripper plate. The stripper plate coming down onto the tooling. The next ones are the punches coming through, and then you have the coining forming of it. And then the next little dip on the end is the stripper plate coming back up where it flattens out. So all this looks unusual, but it does really have something to do with your tooling and your forming of your condition. Another thing always is a human error or human effect on the machine. So depending on how they run it or how they operate, the process is a little different. Some people run it different than others. First shift, they'll run it different than the second shift. They'll come in and change everything because they think the first shift is not running well. So, and then machine conditions. It's always good when the machine is running over a period of time. A long period of time, it warms up, it always runs better. You don't want to stop the machine. So that's why we help to have sorting gates to hook up to it. We want rather you kick out these bad parts than stop the machine unless it's a catastrophic thing going on. So it's more of the sensors and the temperature in it. And this all affects the final product. So the final product is always affected by all these conditions. So condition monitoring are several different things. We talk about in-process monitoring. We could talk about condition monitoring of the machine and the tooling itself. And then we can measure condition monitoring over a longer period of time. So in the past, condition monitoring of a machine, you're going to hear it. The operators of old, they can hear the sounds in the machine. They can hear what's going on. They can feel different heating up of the machine, so you can see the difference of what's going on. Nowadays, we don't have the operators that can do that. They don't know the process of how it runs and what's going on. So presently, for machine conditioning, is they have simple sensors on the machine, overload sensors, just to protect the machine itself. The future is going to be automated, where the condition sensors are going to be put into the machines, and it's going to be automated production. So everything's going to be run, not without people, but not lights out, but they're going to be less operation. The current situation for condition monitoring, usually someone wants, for a machine condition, they want a certain application. The bearings are affecting. We want to monitor the temperature where the bearings are, or some vibration they're looking at. They're looking at a complex system that they want to put a spectrum analysis machine on, monitor on there, like an oscilloscope with all the bells and whistles, just to look at this certain application. There's nothing really involved with an overall machine protection. So it's a standard solution. You're looking at something individual. What's the value of condition monitoring? Well, of course, the worse it gets, the higher the cost. We start out, maybe there's a little vibration. It'll happen over a period of a month, small vibration in the machine, and it not noticeable, but the machine is acting up a little bit. Then it starts heating up a little bit. Costs go up a little more. Now when it's audible problems where you're hearing the squeaking and all that, in a matter of a short time, you're going to see smoke on the machine, and the slide's going to freeze up, and now you have your machine down for 6 months replacing everything, you know, and then the downtime for the machine, the downtime for the operator, everything is going to be high cost before the machine stops itself. So that's more of the overall condition monitor. There's a couple different condition monitoring of tooling. So if you look at the tooling condition monitoring, we're looking over a shorter time. We're looking over trending of tooling coming down over a period of a couple hours or days as the tooling wears down, things wear down in there. We can see the condition of that and we can adjust it. So that's a little more related to the article of the thing, of the die process. The other thing is the machine condition monitoring. Machine condition monitoring is over a longer period of time. We're talking weeks, months, years of vibration and different effects that wear the machine down and make it where it's not runnable or breaks down. So we're looking at both those type of aspects. For a system normally, we usually have like a HMI that displays the sensors, displays the signals, displays what's going on. You have sensors that go into a junction box which plug into the interface, and normally a trigger. For condition monitoring, you want to trigger it at the same time every time to get the exact condition. So you're looking at the same condition always. And like I said, the interface to the machine and also to, I won't bore you with the ERP and all the MES information and charts, but we're able to send information directly to there. We're more of a unique situation where we are flexible to send information. We can get information from an existing SAP system or ERP system that we can get jobs put directly to our controllers, and the operator just goes from one job to the next, and it's already loaded in there. So the different monitoring I was talking about, the first method of monitoring is the process monitoring, the in-die monitoring. So in-die monitoring, you can see it has the progressive header with all, or progressive former with all the sensors behind the dies themselves. So we're looking directly at the signals in the dies and how it's forming to see what the process is. So that's in-process monitoring. The next method is condition monitoring of the machine. So now we're looking at the overall tonnage of the machine. So on the frame itself, we're looking at the condition of the process of what you're going overall. You're not going to look up at little small details with the frame sensors. You're not going to see that. We're looking more of the load and how much load is on one side compared to the other. That type of conditioning. The next method also after that is vibration. So you can have vibration on the machines to see the tooling when the job is, the machine is vibrating more than when it is before. So we can compare, and I'll show more of the signals of each application so we can compare of them. This is the monitoring system that we normally have. It's a real simple system. We have a heads-up display that we call a cockpit situation where you can see everything at once. We have the curves over in the lower right, where if we want to look at the curves, we just touch the screen and it goes to the curves. You don't have to go through different menus to figure out what the curve is. Everything's up there to look at. You always have the machine speed, the variation range that you have. The bars in the middle are the maximum forces, so it's something you'd see on other monitoring systems where they have the forces going up. We can see each station of what's happening. You can store jobs in this, so you can store the curves of what you ran in the past, and you can bring them up to see and compare them to what you have now. The good thing about the curves is you're looking at a curve of what's going on. A lot of the time, you have a peak number, you're not really seeing what's going on. And if you look at a curve, you're seeing the process of what's going on. And a lot of the times, they're just hitting the stop blocks. And all the pressure is on the stop blocks. And you'll see a hump of the stop block pressure, and then you'll see the tools coming down. And it really overloads the machine by putting all the pressure on the stop blocks rather than the tooling itself. And we do work with Bruder on height adjustment on a stop block where we can measure the pressure on the stop blocks and automatically feed back information to the Bruder press, the new style Bruder press that can adjust the shut height as the machine is running. So we do applications with it. So they have their own system that they have, but over here they like to use our system because it's more of a interactive system and it's more sensitive than the Bruder system that they supply with it with the distance sensors. So like here, everything's pictures. So the operator's easily picked up on what it is. We just have counters down here. The curves, like I said, you can touch the screen and look at the curves or touch the screen and look at the max forces, and it'll blow it up to the individual one. Here's the one for the sensors. It's behind each tool so we can see what's going on. So you'll have 5 sensors. The closer to the process you look at, the more sensitive your system is going to be. This is condition monitoring of the frame. So on this, we have the sensors hidden behind some plates, but you can see some pictures up there. They're frame-mounted sensors, and here are the outputs. So here's the curves of the outputs of the screen. You can see the input side where the parts are fed into over there. You can see the bar chart on the side. It's a little bit higher for us than over here where the parts are coming out. So you can compare the tonnage on there. We can add the signals together and come up with your overall curve of the tonnage of what's happening. Another unique thing is when you're running this process, you want to see what's running through the tooling. You'd like to have a bell chart of the force. You want the force in the middle. So we also have a tilting output. So we compare the forces and then we show where the force is tilting. So maybe there's more pressure on this one on the input side. So there's more force happening on the input side than the output side. So your slide is going to be tilting if you do too much of that. So the process signals, you can see here on the left side, process monitoring, all the different forming stations, they show different force curves. So every force curve is a little bit different because it's a different die alignment and die tooling. So when we're running it, you can see what the forces are, and you can compare them to the forces that ran before. So you can bring up the old jobs and see what the curve looked like initially. You also have the in process of the machine frame information that we just showed you. On the right-hand side, it's the condition monitoring of the machine, where you can see the frame inside force and the output side, the total forming and the difference tilting. So this would come up on a screen when you touch the force curve. So you can see all that. And then if you want the envelope limit above, you can hit on the screen itself and lower the limit and tighten the tolerance on it. So you can run it fairly sensitive to monitoring. In the machine conditioning, we can have different applications and we can adjust them different ways. So now it timestamps and sends this information to a file. It also displays it on the machine. So what we're looking for with condition monitoring of the machine, not process monitoring, but condition monitoring, we're looking for certain conditions to basically stop the machine and say, listen, we want to stop it. So what we have is on this one, all these are stops. We have the date, time, the limits of what the limits were set at and what the warning limits were set at and the actual stop of what happened. So it stopped a bunch of times, and that's okay if it stopped. We say, okay, it's 110% of the tonnage that happened, so we want it to stop. But if it stops more than 14 times in a row, we want to switch it off. We want to say, hey, get a manager, get someone, it's shut off 14 times within a minute, and something else is wrong. You can't keep running it. So if it goes 110 above the tonnage, 110% above the tonnage, it's okay to do that once or twice, but not 14 times in a row. And that can be changed and adjusted by, the company. We can work with you guys on what can be done. So you want to be able to be flexible in adjusting it. You can adjust it between 100%, over 100% of the load, depending on the tilting. If you have so much tilting, you can shut it down. Here we have number of overloads, the peak overloads. We could say, okay, if it's 200%, definitely shut it down. The tilting, you don't want to tilt it too much on some sort of tooling. That's more of a tooling or die design that you want to be aware of, so that's it. So condition monitoring, this is monitoring on the input and output side of the machine. So you're looking at the machine, the vibration. So we're just looking at vibration of the machine. One thing with vibration of the machine and overall conditioning, you want to look at a certain time and you want to be repeatable of what you're looking at every time. It's not good to it's usually done periodically. It's not something that you want to do on the same job every time. You don't want to look at the same job every time because of referring back to that condition in the beginning, the different conditions that happen, the temperatures are different. Some of the tooling might be different. It's the same job, but some things might be different in different applications. So you want to have everything the same. So we have it where you have condition monitoring where you run the machine empty. You run it idle with no parts and you run it at the same exact speed every time. So now you have the same conditions every time to figure out where the movement is in the machine, where the vibration is in the machine. This is a little bit of the outputs from the vibration. You can see the dotted line, bottom dead center, top dead center. If you notice the dotted lines on those, right where it is, there's less vibration. That's because the RAM is coming up to a certain point and slowing down. Then it starts going down, and then a little bit more vibration happens as it's going. So per every stroke, you can see there's more vibrations, halfway down when it's coming. So that's just a little bit of the vibration that you're looking at. This is comparing vibration on a bigger sense of a brand new machine compared to an old machine from 1979. So you can see the bottom dead center, where it's slowing down towards the bottom and coming back up, but you can see the the vibration on the other areas. So you can see it's a lot more vibration on the older machine. And with this, they can have a limit set up where we can adjust the limit depending on the area and have this information sent back, and it can be recorded in your system too, your data. But that's with the overall information. They can also do it with the FFT sensors or the spectrum vibration sensors, where we can see exactly the trigger is at 90 degrees. So you have the X, Y, and Z axes that you're looking at every angle for the force, and we're looking at the same exact time. Every time we're triggering at the 90 degrees, and down below you can see you have 0 to 2.5 kilohertz. We can see where the vibration is happening, you know, what range the vibration is happening on this particular machine, and we can compare signals to other machines. So, like I said, a normal situation for condition monitoring is just 3D sensor, and then we normally have an interface in there where it interfaces with the trigger or gets a signal from the machine itself of a cycle signal at the same exact time every time. And it's an identical situation where it's identically running at the same speed and no load condition. So that's always the best condition for looking at the machine condition monitoring. I won't get into all the different screens of what we do, but we have our own MES system, but we're a wide company where we have software companies within, and they have developed systems where we can communicate good with, we're doing a project with Plex, where we send immediate data information from the machine. Within milliseconds, we can send the information to the ERP system or SAP system. You know, we can send back and forth through SQL files or OPC UA interface. We have a bunch of ways to interface with it. We don't really sell our main system, the ERP. We kind of work together with other ERP systems to send the sensor information to that system. So we work a lot with it. We also have terminals that we can put on machines separately, kind of just like the same as the Wintris was just explained, their system, but we have similar applications for that. But we're more in-die sensing and monitoring the sensors in the dies, and we're steering away. We can affect distance sensors. We work together with distance sensors too, but our main thing is in-die sensing for piezo sensors and looking inside. We can apply them to different sensors though as well. We do. And that's it. I made it quick for you, so you can go home. Quick and easy. So,
Thanks, Joe. Thank you, Joe.
yeah,
Any,
no problem.
any questions for Joe?
Obviously a tremendous amount of data in all of those wave profiles.
Yep.
How much, how long do you store that? And how accessible is that to external systems to see either a snapshot of the profile or all of the actual data content?
Yep, we actually are asked that a lot to send information out. Everyone wants the curves sent to their PLC, and we don't really do that, but we do send it to one of our systems outside onto a server. And we have it where we can access, I was going to put that one up there too, but we have the access to look at the curves, and you can set, as big as your server can hold, we can have the curves sent out onto the server, and we can access them, and we can actually file them ourselves. We work with a lot of different companies on hand where we can work ourselves, and you can look at the reference of the curves as, you know, the last 1,000, and they can overlap each other, so you can see where the trending is happening. We call it the trend viewer. And we can view the trend over a period of time. You can see the actual line in the peak force of the trend, or you can bring up the curves and see the overlapping curves. You can say the last 1,000 curves, the last 10,000 curves, and they're overlapping. So then you can see the trend of how it's up high and goes down low, or you can see how it's low and it's a sharp tool and it gets duller, so the pressure goes up because it's not as sharp anymore. So you can see the different forces and what's happening with it, along with whatever you're looking at for the curves. So you see a lot of information from that. But yeah, we do get that asked a lot, and it's not feasible for us to send the sensor signal up, but are we able to store it? We can send that, so. Cool. That's it.
Joe?
All right, thank you.
Thank you, Joe. All right, so that's a wrap. I want to again thank our sponsors, our all of our speakers, and of course, all of you for attending in person and online. So thanks for being here. Hope we can see you at future magazine and PMA conferences. There's a schedule of upcoming events in your folders. So I wish you all safe travels. And again, thanks for being here.